All right, guys. So in the last video, we did 10.1 notes. In this video, we're going to be doing 10.2. It says, which cookie has the most chips? So is there a difference in the number of chocolate chips in Chips Ahoy cookies versus the number of chocolate chips in a brand called Major Chipsters? So each pair of students will count the number of chocolate chips in chip one, in one Chips Ahoy cookie and one Major Chipsters cookie. Due to the factory's processes, we can assume that the population distributions of number of chips are approximately normal and that the samples are random. Now, obviously, we don't have a physical classroom, but let's just say, for example, you and your partner had 22 chips in Chips Ahoy cookie, and you had 18 in the Major Chipsters. Now, obviously, answers would vary. Some students might find 20 in their Chips Ahoy or 17 in Major Chipsters. Those answers could vary, right? Now, let's say in the Chips Ahoy, just as an example, we had 28 students, right? So our sample size is 28, okay? In the Chips Ahoy, they had an average of 21.56 chocolate chips per cookie and the standard deviation of 2.49. For Major Chipsters, let's say you averaged 18.22 with a standard deviation of 4.51. Now, the difference, because we're trying to look at the difference in chocolate chips in each one, right? So if I did x1 minus x2, I'm going to get a difference of 3.34. Now it says if we repeated this process many times and created a dot plot, we would have the sampling distribution of x bar 1 minus x bar 2. Describe the shape, center, and spread of the sampling distribution. Now, it told us that both of these distributions, both population distributions, are approximately normal. So we can assume that the distribution of these differences will also be approximately normal. Okay, now for the center, okay, the center of x bar 1 minus x bar 2 is just going to be equal to whatever you think mu1 minus mu2 would be. All right, and then for the spread, if we knew this population standard deviations, it would be something like square root of mu1 squared over n1 plus mu2 squared over n2. Now, we don't know what the population standard deviations are, so what you could do is you could find the standard error instead, x bar 1 minus x bar 2, and that's just going to be standard deviation 1 squared, so S1 squared over N1, plus standard deviation 2 squared over N2. All right, now have the conditions for constructing a confidence interval been met and explain. So first off, we got to check random. Okay, so for the random, it told us that these, well, first off, they're independent, right? We have to make sure that they're independent random samples because, in other words, you can't have one item that's in both groups. And in this case, you can't have that because it's either a Chips Ahoy cookie or it's a Major Chipsters cookie. It can't be both types, right? So we have independent random samples. It told us that they were random in the problem, okay? So that one's good. 10%, okay? So 10% rule. So we had a sample of 28 people in the class, so each one of these are 28, right? It's safe to assume that 28 is less than 10% of all Chips Ahoy cookies, and 28 is less than 10% of all Major Chipsters, right? These are big companies. They make a lot of cookies, right? So safe to assume 28 is less than 10% for both of those. And then the last one is normal. Okay. It told us the population distributions are approximately normal. Okay, so population distributions are approximately normal. Okay, so since it told us that, we don't have to worry about checking anything else. And you'll notice that we did these conditions for both groups. I'm going to write this in all caps, both groups. Okay, you have to do it for both groups, otherwise it's not considered done. Okay. Number 5 says construct a 95% confidence interval for the true difference in the mean number of chocolate chips in Chips Ahoy and Major Chipsters. So remember, confidence interval is just equal to your point estimate plus or minus your margin of error. Okay, so if I wrote that out, it's the same thing as x bar 1 minus x bar 2, okay, plus or minus t star times our standard error. So square root of s1 squared over n1 plus s2 squared over n2. All right. Now, you might be thinking, how do we get t star, right? So t star, remember how we said that we can use inverse t on our calculator, but you need to know your degrees of freedom. So because we have two different groups, you always want to pick the group with the smaller sample size. Now, in this case, both groups are size 28, so it doesn't really matter. So our degrees of freedom is, in this case, is 28 minus 1, which is 27. But I'm just going to write a little side note. Pick smaller sample size, or smaller n, of the two. So, for example, sometimes you might have it to where one sample size is size 28, but then the other one is size 15. If that's the case, then you choose the one that's size 15 to create your degrees of freedom. Okay? So, for my t star, we're going to have inverse t. I'm creating a 95% confidence interval, so my tail is 0.025. My degrees of freedom is 27. So I'm going to get a t star of 2.052. All right, so going back to our equation, I'm going to have x bar 1 minus x bar 2. We calculated that earlier, and we found a difference of 3.34 plus or minus t star, which is 2.052, times the square root of 2.49 squared over 28 plus 4.51 squared over 28. Take the square root of that whole thing. And so I'm going to get a confidence interval of 1.34 up to 5.34. All right. Now, something else to note is that this is a conservative degrees of freedom. Okay. What I mean by that is there are functions in your calculator that can do this entire process on its own. The only thing it asks for is your sample means and standard deviations. You plug those in, hit enter, it'll do everything else by hand. You obviously don't, you can't put that information as your answer on a free response question, because on the free response question, you need to show all of these things, show all your work in order to receive full credit. You have to manually calculate all of these things. You can have your calculator help find your t-star, but you still have to show all of this work by hand, okay? So this 28, this 27 right here for your degrees of freedom, that is what's considered a conservative degrees of freedom, okay? So I'm just going to write a little note right here. This is a conservative DF, okay? Your calculator will give a larger, more accurate degrees of freedom, okay? Your calculator will give a larger, more accurate DF. Okay, so for example, on this one, the calculator will give you a DF of 42.06. Okay, it uses a much larger formula to do that, something that you don't really want to do by hand, even if you knew the formula. It's a very, very long process. But for the sake of ours, when we're having to do it by hand, this 27 is perfectly fine. Okay. Now it says, do we have evidence that there is a difference in the average number of chocolate chips in a Chips Ahoy cookie and a Major Chipsters cookie? So if you look at our confidence interval, 1.34 to 5.34, if there was no difference in our brands, in Chips Ahoy versus Major Chipsters, if there was no difference between them, then our difference would be 0, right? But our confidence interval shows all values in that interval is greater than 0, okay? So since 0 is not a part of that interval, that means we do have convincing evidence, okay? And you always got to look at, okay, well, convincing evidence which way, Chips Ahoy or Major Chipsters? Well, if you look at, we did X bar 1 minus X bar 2, right? In other words, we did Chips Ahoy minus Major Chipsters, and we got a positive value. We got a positive interval at the end too, okay? So since we're doing Chips Ahoy minus Major Chipsters, that means that if we get a positive value, Chips Ahoy is bigger. Or Chips Ahoy has more chocolate chips. Think big minus small gives you positive, okay? If it was a negative interval, then Major Chipsters would be more, all right? So our interval tells us that all of our values are positive, meaning we have evidence to suggest that Chips Ahoy has more chocolate chips on average. Okay, so it says, do we have convincing evidence? Yes. Okay, because all of our values are positive. So because all of our values are positive, in other words, 0 is not contained. We have convincing evidence that there is a difference in the average number of chocolate chips. Okay. And now for the important ideas, first one is number 4, conditions. It's the same conditions that we've been doing, okay? So you still have to show random 10% and normal/large counts. So random 10% rule and normal/large counts, okay? The only stipulation here is that you have to do it for both groups. All right, and then number 5. Four-step process. Okay. So this is still the same 4-step as before. Okay. The only stipulation, the only difference is that the name. Okay, so in section 10.1, we had 1 sample. This is a 2 sample T interval. For mu1 minus mu2. Okay, so since we have 2 samples, you're going to have to name it that. And then also, obviously, the conditions, you need to check both conditions when doing the 4-step process. All right, so I'm going to leave the check your understanding for you. Again, you can check your key. Check the key with your work if you'd like. We're going to go ahead and move on to this part right here. It says, does memory training help? So it says, does memory training help? You will be given a list of words. You will be given 3 minutes to memorize as many as possible by just rereading the words. You will record as many words as you can remember. You will then be given another list of words to memorize for 3 minutes using memorization strategy. You will record as many words as you can remember. So again, for example, if we had a full class, we will be able to have everybody do this word memorization process. So the first method is just trying to remember, like rereading them. And then the second method was story reading. Okay, so you have to try and string together all of these words together using a story. You just make up a story in your head, try and figure out if you can remember it, right? Now, for example, one of you might have remembered 12 words with strategy 1, but with strategy 2, you got 14. So if we do a difference of strategy 2 minus strategy 1, that means you remembered 2 more words with strategy 2. Another person might do 10 words and 11 words for a difference of 1. Another one might be 10 and 15 for a difference of 5, and so on, right? So let's just say, for example, that on number 4, it says make a dot plot of the differences below. So let's say, for example, all of these were filled out for each one of us, right? Now, the main thing I would be looking at, okay, each person has 2 different strategies and 1 difference. So these differences are what we would want to be looking at. So everybody's differences. What was the difference in your words for strategy 1 versus strategy 2? Okay. Now, for example, let's say that I created a dot plot using those differences. Okay. So I just have some data from another class. I had differences ranging from -3 up to +8. So 3, 2, 1, 0. All right, so -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. And so each one of these dots I'm about to put on this dot plot represents a difference that one specific student got. So I had one student who got a difference of -3. I had 2 of them get a difference of -2. And then another one of -1, and so on. So I got 3 zeros, 3 ones, 5 twos, I had 4 threes, 4 fours, 3 fives, and an 8. And so these were the differences that each student got in their strategies. And so if you think, oh, strategy 1 minus strategy, or strategy 2 minus strategy 1, if you got a difference of 0, that means you did the same with both strategies, right? In other words, this would be no difference. There would be no difference between the two strategies. Now, if you had one or more, this would be where strategy 2 is better. Okay, if you think about it, strategy 2 minus strategy 1, you get a positive value. That means that strategy 2 is better. And if you had a negative value, that means strategy 1 was better for you. Okay? And so this dot plot represents the differences. In parentheses, I'm going to put strat 2 minus strat 1. All right. Now, it says, what does the dot plot suggest about the memory training? Well, if you count, you're going to see that 20 out of 27 students did better with strategy 2. Okay, so that suggests that strategy 2 actually is the better of the two methods. So if I calculated the mean and standard deviation for this, I'd have a mean of 2.07 and a standard deviation of 2.51. And it asks us to interpret this mean. So a mean is an average, right? So that means on average, a student remembers 2.07 more words using strategy 2. So a student remembers 2.07 more words using strategy 2. Because think if it's positive, that means the strategy 2 did better, right? Now, we're doing two strategies for each student, right? Strategy 1, strategy 2, and we're looking at the differences. So this data is paired to one student. We have two pieces of data paired to one student. So this mean has a name, okay? We usually use X-bar for sample mean, but this one is called mean diff. Same with the standard deviation. This is S diff. Okay? So when you have paired data like this, we're looking at mean diff and standard deviation diff. And now it says construct a 95% confidence interval for the true mean difference in words remembered by students using story rather than rereading. So again, same exact layout. Okay. In the state section, I need to know my parameter and parameter, confidence level, and in this case, statistic as well. So my parameter. So if our sample is represented as mean diff, then our parameter is just going to be mu diff. All right, so mu diff represents the true mean of the difference in words to remember. And then confidence level is 95%. And in this case, our statistic is X bar sub diff, which is equal to 2.07. In the plant section, we need to know the name of the procedure and also check our conditions. So we have one mean difference. So in this case, our name is going to be the same as the first video we did, where it's one sample, T interval. And in this case, we're doing it for mu sub diff. And then our conditions, again, I got to check random. Okay, so in the experiment, we would actually tell, okay, you do strategy 1 first, then strategy 2. Okay, you are going to do strategy 2, then strategy 1. So we're randomizing the order. Okay, so the order of treatment is randomized. Okay, so because of that, we can say it's random. For the 10% rule, this one is not needed because we're having everybody do this, so we're not necessarily trying to justify for an entire population. We're just looking at this class specifically, so it's not needed in this case. And then, so that one's good. And then the last one we need is normal. All right, so if I go back to that dot plot, we already drew it up, but you can see that in this dot plot, there's no strong skewness or outliers. We do have one student that's a little bit higher than the rest, but he or she's not so far out there that it needs to be a worry. So I'm just going to say dot plot of differences. Shows no strong skewness or outliers. Okay, so our population it did not tell us our population was normally distributed. We do not have a sample size of 30. Okay, we only have a sample size of 27 students. So we can't say central limit. So the last thing we had to do was draw a graph. And we had already drawn one, and we just had to explain that there was no strong skewness or outliers. So we're good there. All right, now for the do section, general and specific formula. For the general formula, remember it's just point estimate plus or minus our margin of error. For the specific formula, we've got X bar diff plus or minus T star times S diff over root N. Okay, so same exact formula as before. We just have X diff and S diff instead of just X bar and S sub X. So if I plug in my numbers, my X diff was 2.07 plus or minus, in this case, T star, remember, inverse T. Inside here, we're doing a 95% confidence interval, so I've got 0.025 tail. And then my degrees of freedom, well, DF is equal to 27 minus 1, which is just 26. So I'm going to get a T star of 2.056 on this one. So I'm going to have 2.07 plus or minus 2.056 times 2.51 over square root of 28, or excuse me, 27. So I'm going to get 2.07 plus or minus 0.99 for a confidence interval of 1.08 up to 3.07. So my answer here, 1.08 up to 3.07. Okay, and then the last thing, interpret this. So we're doing a 95% confidence interval. So I can say we are 95% confident. The interval from 1.08 to 3.07 captures the true mean difference in words remembered using story over rereading. And now it says, do we have convincing evidence that there is more words remembered using a story instead of rereading? So if we look at our interval, our entire interval is positive, okay? If there was no difference between the two, then that would be a difference of 0, right? But because our entire interval sits above 0, that means that we do have convincing evidence that stories are better at remembering words than just rereading. All right, so do we have convincing evidence? Yes. Because our entire interval is above 0. Okay. And so last thing, important ideas. Okay. So number 6 bullet point, this would be distributions of differences. Okay, so if you were looking at a distribution, typically you're going to have 0 in there somewhere. Okay, so 0 represents no difference. And then everything above that or below that is a difference. Okay, so this would be a positive difference. This would be a negative difference. And then don't forget your statistics, okay, are X bar diff and S diff. Number 7. You've got confidence interval for paired data, okay? So confidence interval for paired data. So the biggest difference, okay, the name of the procedure. We only have one set of differences. So it's going to be one sample T interval for mu sub diff. All right. And now the specific formula. Basically the same thing as it's always been. It's just X diff plus or minus your T star times S diff over root n. All right, so I'm going to leave the check your understanding for you. Got the key on here if you need it. And then in the next video, we're going to be talking about chapter 11.